For millennia, we have treated logic as an architecture of strict, unchanging rules. But when we observe the brain under modern neurological imaging, that rigid architecture shatters into a fluid, biological state. Since antiquity, formal logic has been regarded as the definitive science of correct reasoning, a permanent yardstick for determining what is true. This creates a structural tension. We live in a universe defined by continuous, fluid evolution, yet we attempt to measure it using static, binary tools. The continuity theory suggests that logic is not a fixed set of rules existing outside of us. Instead, it is a regulatory continuum, a specific type of organizational framework that emerges from underlying cognitive processes. To understand how the mind generates reasoning, we have to track this evolution. We will trace the mechanics of thought from classical antiquity through the 17th century philosophy of illumination into the mathematics of dynamic logic, and finally into modern neurobiology. We begin with Aristotle. His historical objective was to identify universal, immutable principles of valid inference that operated entirely independent of empirical observation. This ancient codification prioritized internal consistency over environmental adaptation. The validity of a deduction relies strictly on its structural syntax, regardless of whether the underlying reality is evolving. This diagram illustrates the core assumptions of Aristotelian logic. It requires fixed categories and strict binary truth values. True equals 1, false equals 0. For this system to function, the identities of objects and concepts must remain perfectly stable while operations are performed. Treating variables as isolated, unchanging entities proved successful for building classical mathematics and the foundations of computer science. Because classical logic demands these stable identities, it cannot natively process dynamic state changes or continuous biological evolution. By the 17th century, Persian philosopher Mulla Sadra recognized this structural limitation within the Illuminationist school. In his early logical treatise, Eastern Landmarks, he systematically addressed the boundaries of classical reasoning. Our analysis relies on Dr. Abdülmohsen Meshkatodini, highlighting the transition from logical rules to experiential wisdom. Sadra arrived at a specific conclusion. Logic is not the source of truth, but an instrument used to protect the intellect from error. He drew a distinction between external reality and mental concepts. The concept of fire is a representation, not the burning reality. Language establishes boundaries, but never exhausts the actual existence of a thing. Reality is richer than definitions. Logic organizes thought and protects it from internal contradiction. But perceiving reality requires a deeper integration than formal rules allow. This vertical matrix outlines Mulla Sadra's cognitive hierarchy. Knowledge begins as the brain gathers sensory data, moving upward to trigger concept formation. In the middle, logical reasoning emerges as an organizing bridge between perception and higher understanding. Unlike pure rationalism, which stops at formal deduction, Sadra argued that reason must be pushed further through intellectual purification. At the apex of this structure sits illumination, or ishraq, the completion of the cognitive hierarchy. This is intellectual presence, a state of direct certainty where the separation between the knower and the known is resolved into unity. Treating logic as the final goal of cognition limits our understanding of the brain. It is a structural stepping stone that requires completion through this higher-order integration. Moving forward into the 20th century, rapid scientific advancement forced formal mathematics to confront continuously evolving systems and changing knowledge. In 1965, mathematician Lotfi A. Zadeh broke from classical static limits with the development of fuzzy logic. This chart demonstrates how fuzzy logic dismantles the strict binary constraint. Instead of jumping from 0 directly to 1, it introduces continuous truth values along a gradient. This allows the world to be represented accurately, without imposing artificial boundaries. This opening led to modern dynamic and temporal logics. These systems are designed to investigate actions, state transitions, and the flow of time. The focus shifted from what is statically true to how does truth dynamically evolve as complex systems change. The Brain Kinematics Model, or BKM, maps this transition from chaos to logic by looking at the physical strain and flow within neural systems. Logic is not a pre-installed faculty, It is an emergent organizational state that appears when neural signals become sufficiently integrated. We can map Mulla Sadra's hierarchy directly to the regulatory fields identified in BKM. Sadra's sensory and concept layers correspond to loosely coupled sensory regulatory fields and the formation of memory-building strain patterns. As these patterns reach an organizational threshold, logical reasoning emerges as a coherent organization. Finally, Sadra's illumination aligns with BKM's state of maximum global regulatory coherence, where logical consistency and intuitive organization coexist. Logic is an emergent topological phase, bounded below by instinct and bounded above by total integration. This model of cognitive regulation is part of a broader organizational principle, the universal regulatory continuum. This table illustrates that the divisions between physics, biology, and philosophy represent different degrees of organizational complexity rather than separate realities. At the simplest level, gravitational and electromagnetic interactions regulate large-scale structure and molecular stability. Chemical dynamics then build on these interactions to create self-organizing reaction networks. Biological systems transform these chemical networks into adaptive homeostatic regulation. As neural systems evolve, they generate increasingly flexible regulatory fields to manage complex behavior. Cognitive logic is the next stage in this progression, a coherent regulatory state that allows for predictive reasoning. When this coherence reaches its maximum, it culminates in illumination. Matter and mind are progressively complex expressions of one continuously evolving regulatory architecture. We can no longer view formal logic as an isolated discipline or final metric of truth. The question is no longer, is this inference valid, but rather, what regulatory continuum organizes this reasoning, and how is it evolving? The evolution of human logic mirrors the evolution of nature itself, a drive from basic regulation toward integrated, illuminated complexity.